Hello everyone, this video is about partial fractions decomposition. We have three types of partial fractions. If you see this in the denominator, we use this form, and if we have this in the denominator, we use this form, and if we have this in the denominator, we use this form. For this example, the first thing we want to do is to check whether it's a proper fraction. Check the order, just x, the order is 1. This is x times x squared, so the order is 2. And the denominator is just x plus 1, so we use this type. And for x minus 4 only, we use this type, the linear. And then we multiply both sides by the denominator x plus 1, x minus 4, both sides. On the left, we cancel out, we have only 5x. On the right, when we do the first term times this, we cancel out the x plus 1, so we have only a times x minus 4. And when we do the second term times this, we cancel out x minus 4, we have only b times x plus 1. And now we have to choose certain values of x so that we can find the coefficient a and b. We use the zeros of the factors. The x minus 4, we have to use 4 because when we plug in 4, we cancel out, this is just 0, and we have only 4 plus 1 is 5b, so we have 5b equals 5 times 4 is 20, and so we can find the b. And we can also do the same thing with minus 1, because if we plug in minus 1, we get minus 5 equals, from here we have minus 1, minus 4, minus 5, so minus 5a, plug in minus 1, and this is 0, and so the a is 1. That's it, we're done. In conclusion, the a is 1, the b is 4, so this is the partial fractions. Next example, again, we check, make sure it's a proper fraction. The order is 1 because of x, the order is 2 because of x times x squared. For the x minus 2, that's just linear. For the x plus 3 all squared, that's repeated linear, so we use a constant divided by x plus 3 to the power of 1, another constant divided by x plus 3 to the power of 2, and then we multiply both sides by the denominator, we cancel out, we get this. And from the first term, multiply, cancel out x minus 2, we have a times x plus 3 all squared. From the second term, cancel out 1 x plus 3, so we have b times x minus 2 x plus 3. And for the third one, we multiply again, cancel out x plus 3 all squared, we have only c times x minus 2. So now we can plug in minus 3 so that this is 0 and this is 0. We can plug in 2 so that this is 0, this is 0. If we plug in minus 3 first, we have minus 75. Plug in minus 3, we get 0. Plug in minus 3, we get 0. Plug in minus 3, we have minus 5 times c. Therefore, the c must be 15. And if we plug in 2, we have 25 times 2, 50. Plug in 2, we have 2 plus 3, 5. 5 squared, 25, 25a. Plug in 2, 0. Plug in 2, 0. So we have a equals 2. Since we have the a and the c, to find the b, we can plug in any random number. But of course, it's easier to use simple numbers like 0. If we plug in 0, 25 times 0 is 0. If we plug in 0, we get 3 squared, 9. 9 times a, but the a is 2. 9 times 2 is 18. For the b, we plug in 0, minus 2, plug in 0, 3. Minus 2 times 3, minus 6, so we have minus 6b. Plug in 0, we have minus 2. We have the c is 15. Minus 2 times 15, minus 30. And then we solve for b, the b must be minus 2. And so the final answer is, we have the ABC, just rewrite. Next, in this case, the order of the numerator is 3, and the order of the denominator is also 3. So it's an improper fraction. If it's improper, we have to do polynomial long division first. So we first expand at the denominator the usual way. We have this form, and then we do the polynomial long division. From the polynomial long division, we get the quotient and the remainder. For the divisor, we use the original form. And now we do the partial fractions decomposition only for this part right here. So we're just rewriting right here. The types, we use the linear and the unfactorizable quadratics. Notice that we have a linear in the numerator here, bx plus c. We multiply both sides, cancel out. On the left we have this, on the right we multiply, cancel out. We have a times x squared plus 6, and when we multiply this, cancel out, we have bx times x minus 3 and c times x minus 3. And now we have to plug in some values of x, and as you can see here, we have 0 and 3 for the zeros, so we can plug in 0 and plug in 3. Now if you want to plug in 0 first, this term goes to 0, but this is not 0 and this is not 0, so you don't want to plug in 0 first. You want to plug in 3 first, because this will be 0, this will be 0, we get the a right away. So we have to plug in 3 first, and after plugging in 3 times 6, 54, just plug in 3, plug in 3, 9 plus 6, 15, plug in 3, 0, plug in 3, 0, so we have 54 minus 24, 30, 30 equals 15a, a equals 2. Now we plug in 0, you know the a already, so when we plug in 0, it's just minus 3, so minus 3, and plug in 0, we have 6a, but the a is 2, so 6 times 2, that's 12. Plug in 0, this is 0, plug in 0, this is minus 3c, so we solve this, the c must be 5, 12 minus 15 is minus 3, so c is equals 5. For the b, to find the b, we can plug in any random number. We can just use the second simplest number, 1. If we plug in 1, we get this, plug in 1, we get 6 minus 7 minus 3, plug in 1, we get 7a, but the a is 2, plug in 1, we get 1 times minus 2 minus 2b, plug in 1, we get minus 2c, but the c is 5, so minus 10, and therefore we get the b, this is minus 4, and this is 4 minus 2b, so b equals 4. So that's it. In conclusion, the final answer is the 1 from the polynomial long division, the quotient, and from the partial decomposition we have the 2 and the 4 and the 5, so this is the final answer. That's it. I'll see you again next time.